Hello, everyone. First of all, this is a special edition. Many thanks to my 1,000 subscribers. This is really a milestone to myself personally. And I decided to take a recording for this recent NHT paper, Specialist Maths Exam 2 in this year. So let's have a look at the multi-choice questions. The first question, consider the following proof. We would like to prove root 15 plus root 7 is greater than root 19, and we assume the opposite. Especially, you will see there is a contradiction established. So this is a proof by contradiction. Next one, pseudocode question. The following pseudocodes will be used to estimate the arc length of a certain curve. So we would like to estimate the arc length along this curve, x squared. And we set out an A value and a B value with a step size of 0.5. So I think it's a good idea to sketch a diagram and get an idea of what's going on. All right. So let's try to draw a quadratic. This is f of x equals to x squared. Now, if this is 1, this is my starting point. Let's say 1, 1. And this is 2. This would be 2, 4, I suppose. So pretty much we would like to get this arc length. But the process the question is using, it breaks the curvy bit into 2 straight lines. Because you can see from the pseudocode, my left endpoint is 1. And each time we add 0.5. So 1 to 1.5, and then 1.5 to 2. The while loop says while the right-hand side is less than or equal to b, do the following. Like, look at this sum. At the start, we haven't summed up anything. So the first thing we need to do is using the straight line, the length of the segment from 1.5 to 1. So pretty much it's like square root of f of 1.5 minus f of 1 whole thing squared plus the interval length. So pretty much it's using Pythagoras. 0.5 squared here, okay? That is the first iteration. And then we pretty much count this bit of calculation plus, let me do another duplication, another square root expression here, okay? And the next thing is we need to get left plus h. So that is 1.5 plus 0.5, which is 2. And then minus f 1.5, okay? Once you define the function f of x equals to x squared on your CAS calculator, what you're actually calculating is the sum of these 2 square root expressions, okay? So eventually, use your CAS calculator, you should be able to get it. E, okay? Let's move on and look at the next question. Next question is a graph question. The graph of y equals to 1 over 1 minus x squared minus a needs to have 2 x-intercepts. So if you, let's say, sketch a quick graph of this reciprocal without the minus a at the end, you will see there are 2 vertical asymptotes, x equals to 1, x equals to minus 1. And you will see a U shape in the middle and the 2 outer branches below the x-axis, okay? Now, if you want to have 2 x-intercept, you could consider, okay, once I push this down by a certain amount, this was 0, 1. And if you shift that down by 1 unit, let me use a different color. The outer branches will also be shifted down by 1 unit, and the horizontal asymptote will be shifted down by 1 unit. But we need 2 x-intercept. It means we need to shift down by more than 1 unit. Notice that this is minus a, which means your minus a needs to be less than minus 1. So a is greater than 1. Also consider the other direction. Let's say if we shift this up, just tiny little bit, they'll be able to get the two outer branches to cut through the x-axis, which means you could get minus a greater than 0. So a is actually less than 0, okay? Therefore, I would choose option E. Question 4 is really a nice trick and algebra question. We would like to rewrite this whole equation and write it in terms of tangent only. Pretty much, I would split the first part, like 1 over cosine squared x plus 5 sine times cos divided by cos. This is pretty much 5 tangent x minus 7 equals to 0. The other thing is 1 over cosine squared is secant squared x plus everything. But also notice secant squared is tangent squared plus 1. So write tangent squared x plus 1 in place of secant squared. Eventually, you will be able to get a tangent squared plus 5 tangent x minus 6 equals to 0. And then you can just factorize this quadratic equation in terms of tangent. So you should be able to get a tangent x plus 6 and tangent x minus 1 equals to 0, which turns out to be option D. All right, let's move on and look at the next question. The next question is really a good complex number question. Firstly, you need to get the discriminant of this quadratic in terms of a only. Be aware the discriminant is minus a times I squared minus 4a times minus 5 equals to 36. So now we need to get the a value first. And once we get the a value, we put this back and use the CAS calculator to solve for the values of z, okay? So I'll do a quick demo here. First, we will use the solve button, minus a times I squared plus 20a equals to 36, comma a. So you should be able to get a equals to 2 and a equals to 18. Now remember, with TI ends by, you need to use the solve button, complex solve. You get a times z squared minus a times I times the minus 5 equals to 0, comma z. Given that, a equals to 2. So this would be the first pair of solutions. Then copy this line down and get 18 here. You get a second pair of solutions. Just notice you could actually say, combine these two terms into one to match the form provided in the options. For example, com the norm. This guy, actually, it doesn't do much thing. So you could actually do this one by hand. 1 plus 3i over 6. And minus 1 plus 3i over 6. Okay? So that is question 5. You should choose option A. Question 6, we need to convert an equation of array into the form, Cartesian form y equals to mx plus c. So what you can actually do with your CAS calculator is you recognize z equals to x plus iy and just solve for this y. On the TI, you should be able to solve angle z plus 2 minus I equals to pi over 3, comma y, given that z equals to x plus iy, okay? And once you get this entry on your CAS calculator, you should be able to get x greater than minus 2 and y equals to root 3x plus 2 root 3 plus 1. So the gradient m is root 3 and y-intercept c is 2 root 3 plus 1. Option D. Question 7. It's an Euler's method question, so you could use the command Euler. Right-hand side of your DE, 1 plus 2y, independent variable, dependent variable. The domain, you start with 0 for x value, and you end at 1. And your initial y value is 1. step size of 0.5, okay? So my CAS calculator, I should be able to get something like this. 0, 1, 0.5, 2.5, and 1, 5.5. So this is my final y value using Euler's method. Question 8. Using the substitution u squared equals to x plus 1, the definite integral can be expressed in another form. Well, this was designed by as a very good outcome 1 question, I suppose. It could also be an exam 1 question, but what I would do here is I'll actually go through a trial and error method. First of all, after your change of variable, your limits should not be 3 to 8. So I'll cross out D straight away. The next thing is I will evaluate this one, this one, this one, following the order, okay? To compare with the result given by this integral. So let's have a look at the CAS calculator. Okay. Shift plus from 3 to 8 fraction 1 over x times square root x plus 1 dx. So you should be able to get a natural log 3 over 2. Let's try option A. We have a half integration 2 to 3 fraction 1 over u minus 1 minus 1 over u plus 1 du. So actually, the first option gives me half of the desired value. That means I don't need the half. And you can see option B gives me exactly the same answer, okay? So that is my possible approach to tackle question 8. If I treat question 8 as exam 1 question without use of CAS calculator, I probably will do the following. First of all, u squared equals to x plus 1. That means your u equals to square root of x plus 1. Another thing is, notice this x here. X equals to u squared minus 1, okay? And I do need to get, let's say, du dx. The du dx is 1 over 2 root x plus 1. Okay, and it means I could write 2 lots of du equals to dx divided by root x plus 1. So in the structure of the original integral, you should be able to get the part I circled in purple as 2 du. And also, if x equals to 3, the u is root 4, which is 2. Your x is 8. The u value will be root 9, which is equal to 3. So the new integral will be written as u equals to 2 to u equals to 3. And because you replace x with u squared minus 1, should be able to get, let's say, u squared minus 1 here times 2 lots of du, okay? And then you can just go for partial fraction, like 2 over u squared minus 1. You should be able to get 1 over u minus 1 minus u 1 over u plus 1. Okay, and let's have a look at the question 9. Question 9 assessed your skills in finding the length of the curve, expressing that as a definite integral. So firstly, you need to get your dx dt, which is 3 lots of 0 minus 2 tangent t times secant squared t. Notice that you are using a chain rule here. And this will get you negative 6 tangent t secant squared t. Now, dy dt, you're differentiating for secant squared t, which means you are going to get a 4 times 2 secant t to the power 1. And notice the derivative of secant is secant t times tangent t. This is another use of chain rule. So eventually you should be able to get 8 secant squared t tangent t. You know you want to square dx dt and dy dt, then add them up. So the arc length should be expressed as pi over 6 to pi over 3 square root of 36 tangent squared t secant to the power 4 t plus 64 secant to the power 4 t tangent squared t dt. Okay? And adding them up, you get 100 loss of the perfect square term. 100 tangent squared t secant to the power 4 t dt, all under the square root. And just notice pi over 6 to pi over 3 for the t values. It's part of the quotient y. After taking the square root of the perfect square term, you don't have to worry about the absolute value because both tangent and secant will be positive anyway. So you actually get pi over 6 to pi over 3, 10 lots of tangent t secant squared t dt. So option A is a suitable option. All right. All right. And this is also a very good possible exam 1 question, I suppose, because you can easily integrate 10 tangent t times secant squared t by letting u equals to tangent t whatsoever. Question 10, surface of revolution, rotating the curve about the x-axis. So let's set it up. Surface area equals to 2 pi from 1 to a, y square root 1 plus dy dx, whole thing square, dx. Now you should be able to get a 2 pi, 1 to a, 1 over x times 1 plus negative 1 over x squared, whole thing squared, dx. Then you just tidy everything up. 1 to a, 1 over x. And you could write 1 over x as 1 over x squared under the square root. And then you get another square root, 1 plus 1 over x to the power 4, dx whatsoever. And then you can combine the second square root expression, say x to the power 4 here, x to the power 4 plus 1, dx. Eventually, you expect 1 plus x to the power 4 under the square root. And x squared times x to the power 4 is x to the power 6. Taking a square root, you get x to the power 3 anyway, and x is greater than 1. So I think you should get option C. When you write it out, don't forget about the dx. Okay, even though this is a multi-choice question, get into a good habit. All right, question 11, integration by parts, I suppose. We have this recurrence relation. The nth integral is 1 to e x squared times log ex to the power n dx. N is any natural number, 1, 2, 3, 4, and n is greater than or equal to 2. Good. So what you could do is you need to select your u dash and the v. In this case, I'm going to select u dash equals to x squared, and u is 1 over 3x to the power 3. And also v equals to natural log of x to the power n, and v dash is 1 over x times natural log x n minus 1 times n, okay? I'm using the chain rule again, so you can see there are a lot of things in specialist math you need to use chain rule. And the integration n equals to u times v between e1 and e. So you get a 1/3 x to the power 3 natural log x to the power n, subtracting the integral 1 to e, v dash times u. So if you multiply these two things, you cancel out an x. So you get a 1/3 x squared times n times natural log x to the power n minus 1 dx. Evaluating this, you'll be able to get a 1/3 e to the power 3 times natural log e is 1 times 1 minus 1/3 times natural log of 1, which is 0, suppose. And then you just need to tidy up the second part. Say you take out the n, take out the 1/3, so n over 3, 1 to e, x squared natural log x power n minus 1 dx. And this can be expressed as I n minus 1. Just notice the index change, okay? So I suppose you should be able to get option D. All right, move on. Question 12, we would like to get a suitable differential equation based on a slope field. Well, this is a very good curve because it looks like an ellipse centered at 2 and 2. So let's try to sketch a possible ellipse based on the slope field provided. So this is a particular solution within this slope field. And we could write this one as x minus 2 bracket squared divided by a squared, which is 1, plus y minus 2 bracket squared divided by 2 squared equals to 1. And if you use implicit differentiation, you should get a 2x minus 2 plus 2 over 4 y minus 2 times dy dx equals to 0. And that's how you generate the dy dx term. Eventually, you should be able to get a half y minus 2 dy dx. And you push this term to the other side of the equation, you get a 2 lots of 2 minus x. Negative 2x minus 2 is 2 times 2 minus x. And then your dy dx is 2 times 2 is 4. 4 lots of 2 minus x divided by y minus 2. And that's how you could get a possible differential equation, which should indicate option E. Technically speaking, you could choose any constant here. For example, you may want to choose a c. After differentiation is going to be 0 anyway, okay? So whatever number you have here, you might have a 4, you might have a 100, whatsoever. That's why you have so many other infinite number of ellipses. Question 13. Question 13, you have a racing car with an initial velocity of 80 meters per second. From the time t equals to 0 to the moment the car stops, the acceleration of the car is given by this quadratic. So we can't use constant acceleration formula. We have to use calculus for the problem solving. And during this time period, the distance the car travels, correct to the nearest meter. So this is finding the stopping distance. So what I want to do is, first, I will need to get v equals to something. So v dash is the acceleration, minus 60 squared plus t. Subject to v naught equals to 80. That is my initial velocity. Once I get the v, I'm setting that to 0 to find the time. Eventually, we use integration over the time period 0 to that stopping time, get the distance, okay? So this is another good outcome 3 question. Use your CAS calculator efficiently. V dash equals to minus 60 squared plus t. Space and space, v of naught equals to 80, comma t variable, comma v function. So this is your velocity function in terms of t. And we can solve this equal to 0 for t. Control enter, you get that t value and integrate 0 to that t value and bring down the velocity expression, control enter. So it's 198.766, almost 199, 199. Option B is the correct answer. Question 14. You have an equilateral triangle spanned by the three vectors A, B, C. We would like to find the value of the scalar product A dot B. So before you find the scalar product, you need to make sure any scalar product you are doing, you need to get the two vectors tail to tail. In this case, I actually will shift the vector A along this direction. Okay. So the angle between A and B is not 60 degrees. It's actually 120 degrees or 2 pi over 3. And then A dot B is the magnitude of A times magnitude of B times cosine 2 pi over 3. So that means because A magnitude equals to B magnitude, you get A magnitude squared. In an equilateral triangle, all sides equal to each other, times minus half. So that means your option B is correct. Tail to tail for dot product. All right, a normal vector to the plane that contains the points 2, -1, -1, 3, 1, 1, and -1, -1, 2. Let's name them as A, B, C. We would like to find a normal vector to both A, B, and AC, for example. Of course, you could do B, A, B, C, whatsoever. So A to B, 3 minus 2 is 1, and 1 minus minus 1 is 2. 1 minus minus 1 is 2. So it's 1i, 2j, and 2k. And A to C, for example, that is -1 minus 2 minus 3. -1 take 1, 0. -1 take -1. And 2 take -1 is 3. Okay? And then you can do a cross product of your vectors A, B, and AC. Use comma to separate two columns or two row vectors. Eventually, you will get 6 minus 9, 6. But there is no option giving you exactly 6 minus 9, 6. Actually, if you divide everything by 3, you get a 2 minus 3 and a 2, which gives you option D, okay? So any non-zero multiple of this vector will also be perpendicular to the plane, including A, B, C, the 3 points, okay? All right, question 16. Position vector of a particle at a time t is given by this guy here. The value of t when the particle's velocity is perpendicular to its acceleration. So you could define this thing. RT equals to e to the power minus 4t, e to the power t. And then, because the velocity is perpendicular to the acceleration, you could solve an equation, dot product, the first derivative of position vector, and the second derivative of the position vector equals to 0 for t, okay? So that is another outcome 3 question, I suppose. So let's say r of t is assigned to exponential minus 40, exponential p. And solve button, dot p. Shift minus t, r of t, comma, second derivative, r of t equals to 0 for t. So 3 natural log 2 over 5. Option D, dog, is the correct answer. Question 17. The angle at which the line with the equation intersect the plane with the equation. So you need to get the direction vector first of the line. √2i plus 1j plus 1k. And the plane has a normal vector, root 2i minus 1j plus 1k. If the line is intersecting the plane, the angle between the line and the plane, we need to use 90 degrees to subtract the angle between the normal and the direction vector, okay? Of course, you could use a shortcut, say, v dot n equals to magnitude v, magnitude n. Let's say this is theta. This is actually half pi minus theta. So it's cosine half pi minus theta. And you could replace this with sine theta, okay? And this is a special case when you get a line intersecting a plane, or the angle in between the line and the plane. And a v dot n, let's say, is 2 minus 1 plus 1 equals to the magnitude of v, which is 2 plus 1 plus 1, root 4. Magnitude of n is also root 4. You can write sine theta here, direct to the angle between the line and the plane. So it's 2 equals to 4 sine theta. And the sine theta equals to half. Therefore, your theta must be, if it's an acute angle, pi over 6. Option A. All right, the shortest distance between two parallel planes, well, it's 2 minus 1, 6. To get the calculation more consistent, I will divide the equation with larger numbers. Let's say by -2, you get 2x plus 2y minus z divided by -2, that is a 12, okay? So eventually, we could use the formula. Distance pi 1 and pi 2 equals to the absolute value of the second constant subtracting the first constant divided by the square root of 2 square minus 1 square. 2 square minus 1 square. So you get a 6 divided by root 9. Let me double check. You should be able to get, let's say, 6 divided by 3, that is 2, okay? Option B. So this method works if you are finding the distance between two parallel planes. My advice is use consistent coefficients. Of course, you could opt in for the longer way, say pick a point on this plane here, say 0, 0, minus 6, and then pick another point on the second plane, say 0, 0, minus 12, or whatsoever, and then do a scalar resolute onto the common normal vector. That is another possible method. Okay, question 19 and question 20. We have two varieties of tomato plants that have yields, the quantity of tomato produced, that are independent and approximately normally distributed. Variety A yields 6 kilograms for the mean value, standard deviation 1.2. So A is normal, 6, 1.2 squared. Variety B, mean yield is 5. So it's another normal, 5, standard deviation 1.5 squared. We would like a randomly selected plant of variety B will have a higher yield than randomly selected plant of variety A. So we would like to find A greater than B. Oh, sorry, actually the other way around. B greater than A. And to find the probability B greater than A, we need to use a linear combination method. Say B subtracting A greater than 0. Combine the variables B and A, and then do the difference. So the expected value of B minus A is 6 minus 5, which is 1. And you need to find the variance first, and then proceed with standard deviation. A common mistake I observe from my students is they will either subtract the standard deviations or subtract the variance, but make sure you recognize it's variance B plus -1 squared variance A, okay? You have to do the variance first, then take a square root of the combined number. Otherwise, you get an incorrect answer. So it's 1.2 squared plus 1.5 squared. And eventually treat B minus A as a whole variable, whole normal variable. So now you can use the norm CDF from 0 to infinity, and the mean value is 1. Standard deviation is 1.2 squared plus 1.5 squared. Okay, and you should be able to get some reasonable answer. So let's have a look. Okay, so that gets you the answer. And let's have a closer look at this one. Actually, let me switch back to my writing pad. I see. This should be 5 minus 6 rather than 6 minus 5. So fix that. It's the second mean value subtracting the first mean value, okay? Which is -1. So this should be -1. And if I get back to my CAS calculator, redo the calculation, it's actually 0.301 something. Option C is the correct answer. You can see option E was designed there to trap the student. If you made a similar mistake like I did, you get the other way around, the opposite. Okay, let's have a look at the question 20, the last multi-choice question. Okay. The thickness of notebooks is known to have a variance 0.04. And the thickness of the textbook is known to have a variance of 0.16. Let's say notebook is X, normal distribution, mu X, 0.04. That's the variance. And Y, textbooks, mu Y, 0.16. So total thickness of random sample of M notebooks. So X1 plus X2 plus ... plus XM. And N textbooks plus Y1 plus ... plus YN. The combined variance is 4.36. And the variance of N notebooks, X1 plus X2 plus ... until XN plus Y1 plus ... plus YM equals to 2.44. Okay, it's not a super challenging question. You just need to carefully read through the question. So there are M lots of identical variance, N lots of identical variance Y. So M times 0.04 plus N times 0.16 equals to 4.36. And N times 0.04 plus M times 0.16 equals to 2.44. Eventually, you just need to solve these two equations simultaneously, okay? And the reason why I don't take the M out and square it is because these are a number of individual independent items. You could not treat it like a dilation factor. Otherwise, you will result in incorrect answers, okay? So let's have a look at the CAS output and confirm the answer. Solve button, curly bracket, 0.04 m plus 0.16 n equals to 4.36, comma, 0.04 m plus 0.16 m equals to 2.44, comma, m, comma, n. 9 and 25, okay? M equals to 9 and n equals to 25. So option A will be the correct answer. Okay, that's the 20 multi-choice questions. Let's have a quick look at the extended response questions. For the extended response questions, I'll only use my CAS calculator where I feel necessary, okay? So question 1, 10 marks, a rational function question. Sketch the graph of f of x on the axis below and label the point of inflection with these coordinates. So if you check 0, 0, must be there. And you could use your CAS calculator to get the second derivative equal to 0 and y equals to f of x. Solve them simultaneously. You should be able to get the point of inflection is at 2 on 3 root 3 and a quarter. Okay, that's y value. And this point is roughly at 1.1 something, I suppose. So it's here. Actually, let's write it properly. And when you sub in 2, you get exactly 0.5 or half. The first part is concave up. And actually, this is a stationary point, okay? This is a stationary point at the start, okay? And the second part of the graph is slightly concave down. It's not a straight line. It looks like a bit straight, but it's actually, it's a bit hard to sketch that probably. So you could actually get some graph like this, okay? All right, yep, I labeled the endpoints. I labeled the point of inflection. Yep, let's move on. The region bounded by the y-axis, the graph of f, and the line y equals to 0.5 is rotated about the y to form a solid of a revolution. A definite integral, find the volume. Okay. So I know I need to use v equals to pi from y equals to 0 to y equals to 0.5, x squared dy. Now the thing is, we need to get x squared in terms of y. So let y equals to 1 minus 4 divided by x squared plus 4. You could actually rearrange these to get x squared equals to 4y over 1 minus y, or other equivalent form. Say it's a separate form of rectangular hyperbola. But all you need to do next is write pi 0 to 0.5, 4y divided by 1 minus y. Don't drop out your dy, okay? That bookends the definite integral. And then you can use your CAS to get the exact answer, which is 2 pi 2 log E2 minus 1. And some of you might obtain something like this. Eventually, you have a pi in the whole expression, okay? Or sometimes you may write it like 4 pi log E2 minus 2 pi, whatsoever. These are all equivalent answers. As long as you don't write decimal approximation or missing your pi, you should be fine. The solid of revolution is used to model an open fish pond where lengths are measured in meters. A waterproof membrane of negligible thickness is to be applied to the interior surface of the pond. So I don't have to double up the surface area inside or outside. Just look at the inside. So find the number of square meters of the membrane needed. Give your answer correct to 2 decimal places. So to get an idea, I'll draw the the solid of revolution. Like it's actually finding it's a bit hard to sketch this contour curve, but outside surface area or inside surface area, because the thickness is negligible, it's equivalent. So what I really want to find is the surface area around the y-axis. So S equals to 2 pi integral from 0 to 0.5 x times 1 plus dx dy squared dy. This is where I would get my CAS calculator and do the small steps separately. Firstly, I would write 2 pi 0 to 0.5 here, and my x is the square root of 4y divided by 1 minus y. Because previous part, I've got x squared here. I need to take a square root for x, positive version. And the next thing is I'll need to multiply by another square root 1 plus d dy. 4y divided by 1 minus y. And I need to square this guy. dy, okay? So be patient with your entries. It takes a couple of seconds to get everything typed up properly, okay? You should be able to get 13.07889, etc. meters squared. Round to 2 decimal places, 13.08 meters squared, okay? And next one, the pond which is initially empty is filled with water flowing in. Filled with water flowing in. That means the positive rate dV dt. Okay, at water rate is the water level rising when the depth is 0.25. This is not a particularly hard or challenging question. Just be aware. This is the shape of the fish pond. You are filling the gaps or hollow space up. And this is your height, okay? So you actually get a V equals to pi, volume of revolution, 0 to h, instead of 0.5, because the height is changing. And you get a 4y divided by 1 minus y dy, okay? It's pretty much just this thing, except for the upper limit, changed to an unknown h. And then you get the VDH. What dVdH does is getting rid of this thing. But the process is once you antiderive this function, you sub in h, sub in 0. So the expression of v is in terms of h. Then you differentiate. You can cancel this bit, write h and h here, okay? So pi times 4h divided by 1 minus h. And then we need to find the rate of the water level, which is the rate of the height. So we need to get dh dt equals to dh dv times dv dt. That is 1 minus h divided by 4 pi h times 0.1, which is 1 over 10. And that is 1 minus h divided by 40 pi h. And eventually at h equals to 0.25, your dh dt is 0.75 divided by 40 pi times 0.25. Something along this line, you get a 3 over 40 pi. And eventually you could round this thing to 3 decimal places, 0.024 meters per minute. Okay. So that question is a related rate. It's done. Question 2, complex number. Given cosine theta plus I sine theta n equals to cos n theta plus I sine n theta, show using appropriate trigonometric identities that the cos theta plus I sine theta to the power n plus 1 is cosine n plus 1 theta plus I sine n plus 1 theta. So it is important for you to actually use appropriate trig identities. Firstly, your left-hand side is cosine theta plus I sine theta to the power n times itself. Okay? And then for the first bit, I would write cosine n theta plus I sine n theta times the second bit. Okay? And the next thing is we will need to actually expand everything. So use distributive law, cosine n theta times cosine theta plus I sine theta cosine n theta. And then you need to multiply these terms out, okay? So you get plus I sine n theta cosine theta plus, be aware, I squared. That's an I squared. Sine theta times sine n theta. What you are going to do next is to collect the real part and the imaginary part for that whole expression, including 4 terms. So this term will be negative sine theta, sine n theta. I'll highlight this term in yellow. And also I'll highlight these 2 terms in orange, okay? So it's cosine n theta, cosine theta minus sine n theta, sine theta. That's one part, plus I lots of sine n theta, cosine theta, plus cosine n theta, sine theta. Okay? And you could combine that as cosine n theta plus I sine n theta plus theta. And that equals to the right-hand side, okay? So the important thing is you need to really show your expansion and use of compound angle formulae. All right, next. Let Zn equals to 1 minus I to the power n. N is a Z plus. Express Zn in polar form. Express Z3 in the form A plus BI. Cartesian form. Z1, Z2, Z3, Z4. Okay, so I need to get 1 minus I to the power 4. And for what values of n will arc Z equals to 0? Okay, need to use polar form. And a perpendicular bisector. So let's go through them using the CAS calculator. Okay, if I insert a new problem, actually I would say Zn is 1 minus I to the power n. Okay, so it's 2 to the power n over 2, ei minus n pi over 4. Or we just write ei as cis, okay? And Zn when n equals to 3, minus 2i. If n equals to 4, that is minus 4. And now if you try to get angle, the angle of this guy, oh, it's a bit ugly, but I can just get a minus n pi over 4. Let's do this. Minus n pi over 4. If the argument is 0, I'm getting, let's say, 2k pi whatsoever. N equals to minus 8k. Just be aware the n value is positive whole number. That means your your K value needs to be Z minus, or if you write 8K, that K should be Z plus whatsoever, okay? Just be aware your radius should not be negative, okay? For polar form. Really need to be careful with the domain restriction for the parameters. Okay, part F. L be the line defined by absolute Z equals to absolute Z minus A plus BI. L passes through the point representing minus 2i and 1 minus I. Find the values of A and B. So where is minus 2i? It's here. Where is 1 minus I? It's here. So let me draw a line like this. So I know if I choose my reference point here, another point must be here by symmetry, okay? Which is 2, 2. This is 0, 0, okay? So that is my A, that is my B, okay? And this is L. It's a perpendicular bisector between 0, 0, and 2, minus 2, actually. Let me fix that. Okay, so that is second last part, I suppose. Yep, just notice this sort of phrase at the bottom of the page. Question 2 continues on the next page. Find the area of the minus segment bounded by the circle and the line L. Give your answer correct to 2 decimal places. What I'm going to do is I'll quickly show you what I would do with my CAS calculator. Z times absolute Z is a circle. Let's get an equation template. Circle, center form, 0, 0, square root of 10. Okay. And what about L? We need to get an equation, a line. It's y equals to 1x minus 2. Yep. And can I find the intercept? This is y-intercept. Here's another intercept. So we would like to find a segment, the minus segment area. Segment. So it's finding this bit, okay? Finding this bit. Can I use a geometry, measurement, area? That is a single item. No, I can't do that. So I still have to do some calculations. For example, you might want to get, I know the radius of the circle is root 10. And can I find the angle measurement here? Okay, so it's like 2.2143, something here. And the question wants me to get the answer correct to decimal places. Good. So we can use the segment area, okay? Segment area formula to tackle this problem. So let's sort out the calculations and then put them together. Okay, let's put it here. For your information, the equation of the line is gradient 1 goes through 0 minus 2. One point is 3, 1. And another point is minus 1, minus 3. So you could actually say this is a small angle alpha. This is also a small angle alpha, okay? Using the congruent triangle. And the theta equals to 2 alpha plus half pi equals to 2 lots of tangent inverse of 1 over 3 plus half pi. And it's approximately 2.21429, blah, blah, blah. Okay? An area of segment is finding this bit. Equals to half times r squared times theta minus sine theta. So half times 10, root 10 squared times 2.21429 dot 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 minus sine 2.214 dot dot dot. Okay, eventually you can round this answer to 2 decimal places, okay? And the answer is 7.07 square units. All right. Okay, so that is one possible approach. Of course, if you wish, you could opt in for some integration, but I wouldn't recommend doing integration for this question because you have to discuss which part is your upper circle, which part is your lower semicircle whatsoever, okay? This page is blank. Question 3, a nice kinematics question. In a computer simulation, a speedy motorcycle traveling along a straight flat road at a constant velocity 20 passes a stationary highway patrol car. 2 seconds later, the highway patrol car starts chasing the motorcycle. The highway patrol car accelerates for 6 seconds and then continues at a constant velocity of v until it draw levels with the motorcycle. So this phrase is important, same distance. Whenever you see draw level, it means same distance. The velocity of the highway patrol car while accelerating in meters per second is given by this thing here. At the end, 8, it reaches the capital V. T is the time elapsed since the motorcycle passed the highway patrol car. It's 2 seconds later. That's why it starts with 2 rather than 0. Find the value of V. Well, if you chuck it in your CAS calculator, you get a V8 equals to capital V. That is 25 meters per second. Find the acceleration. So A of t is V dash of t. This will give you, for example, if you differentiate, you get a 12.5 times pi over 6 sine pi over 6 t minus 2. And you eventually get a 25 pi over 12 sine pi over 6 t minus 2. There are other equivalent versions if you don't do it by hand, because your TI or Casio might be able to change the expression in terms of cosine rather than sine. But it doesn't really matter, because the next part, we want to find the maximum acceleration, which is just the magnitude. So A max equals to 25 pi over 12, which is roughly 6.5 meters per squared second, correct to 1 decimal place, okay? You can also verify that using your CAS calculator. And sketch the velocity time graph for the motorcycle on the axis on page 18 for t greater than or equal to 0. Clearly label any intercept with the x-axis. Just be aware, you have found the v is 25 meters per second. The motorcycle is below that value. I would recommend you use a ruler. Say this is 5, this is 10, this is 15, this is 20. 20, 15, 10, 5. Try to draw this one to the scale, okay? And it starts with 0, 20, 0, 20, okay? So this is your motorcycle VT graph. And after t equals to 8, the police car continues at a constant velocity. So I will write a highway patrol car. Okay, even though this orange curve is not required by the question. Write down an expression for the number of meters traveled by the motorcycle t seconds after it passes the highway patrol car. So the distance equals to 20t. And how many meters will the highway patrol car travel to reach a speed of v at t equals to 8? So just use integration 2 to 8, and then 12.5, 1 minus cosine of pi over 6 t minus 2 dt. Something along this line, okay? And the answer, I suppose, you should be able to get 75 meters. And for what value of t will the highway patrol car draw level with the motorcycle? That is equating the area. I will duplicate a graph over there. Okay, so I need a graph to facilitate my reasoning. All right, so you can see this yellow area is 75. And up to a certain point, let's say up to a certain moment t, capital T, the area of this rectangle will equal to the orange area plus the rest rectangle, okay? So what I'm trying to say is this is t minus 8, this is 25. So 25 times t minus 8 plus 75 equals to 20t, okay? And you should be able to get 25t minus 200 plus 75 equals to 20t. Actually, I need to make a consistent letter use here. Capital T, okay? And you get, let's say, 5 capital T equals to 125. So capital T equals to 25 in seconds, okay? And how many meters will the highway patrol car need to travel to draw level with the motorcycle? So the distance equals to 20 times 25, which is 500 meters. This is a very straightforward kinematics question. Very classic, but very straightforward. Okay, Vector calculus question, I suppose. Next one. Position vector RT from the origin of the drawn t seconds after leaving the ground is given by this thing. IJK, unit vector. Displacement components are measured in meters. Show that it takes 50 seconds for the drone to gain an altitude of 30. So K component, 3t/5 equals to 30. And t equals to 150 divided by 3 equals to 50 seconds. So this is a show that question. I wouldn't recommend you subbing in 50, but let's look at the next part. Find the angle of elevation from O of the drone when it is at an altitude of 30 meters. Give your answer in degrees, correct to the nearest degree. So for the vector calculus question, this is one thing I really want to show you. You know, in the past, when I was recording these videos for Specialist Maths Paper 2, I always recommended define your vector function as a row matrix function, okay? With 3 components. And be patient when you enter all components carefully into your CAS. It will save you a lot of time if you did everything correctly. So this is the vector function, and it takes 50 seconds, so R50. So this is a particular location at t equals to 50. The angle of elevation, well, there are a number of different approaches, but be aware this is a 3D triangle case. You need to find, let's say, this thing squared plus this thing squared. Take a square root as your adjacent. And this is your opposite side in that triangle. Alternatively, you might want to do a norm R50. The length of this position vector from origin as your hypotenuse, and then the 30 divided by that. This method was suggested by another colleague of mine. I think this one makes more sense if you are not so good at 3D analysis, okay? So eventually you'll be able to get 24 degrees, something like that. And after how many seconds will the drone first be directly above the point of takeoff? This is just finding the period of the X and Y component, which will be 60 seconds, I suppose. Directly above the point of takeoff, yep. And the next part is to show that the velocity of the drone is always perpendicular to its acceleration. Like you need to get the velocity function. And also, this is the velocity, and this is the acceleration. So make sure you transcribe the answers carefully onto your paper, okay? And there will be a future part, part D, getting you to work with the speed, find the speed. So the speed is this guy, okay? All right. And the last part of the question wants you to get the minimum distance of the drone to the top of the tree. So you may want to define a distance function, norm R of t, subtracting 60, 25, 8. And F minimum, B of t, between 0 and 60, 1 period. And sub that in to get the shortest distance. You can always confirm this is a distance function of time and sketch the graph to confirm the absolute lowest point. For example, d of x. This is the absolute lowest point. Something along these lines, okay? All right, let me switch back and complete the rest of the working. Put brackets. So you need to carefully transcribe everything onto your CAS calculate from your CAS to your paper, okay? Don't drop out your IJ and K. See, in the process of transcription, it's very easy for you to drop out your I, J, and K. Because this is a show data question, you need to establish a zero for your dot product, but how you get that zero is very important. Say 5 pi times pi squared with a minus 5 pi to the power 3 divided by 216. Cosine pi over 30t sine pi over 30t plus minus times minus is plus 5 pi to the power 3 divided by 216 sine pi t over 30 cosine pi t over 30 plus 3 over 5 times 0. You have to show the actual calculation. And that leads to a 0 clearly. And therefore, you can reach a conclusion the velocity is perpendicular to the acceleration. Okay? Constant speed, you just write velocity t equals to, you may want to write down the answer directly, but my habit is to get an exact answer first, then show the required number of decimal places. In this case, it's roughly 2.69 meters per second, correct to 2 decimal places. Okay. Next part, last part, dt equals to magnitude RT minus R3. Do I need to show the actual equation? Well, it's not harmful to show the actual equation, all right? So I would write 25 sine plus 50 minus 60. This next term is 25 cosine plus 50 plus 50 minus 25, something like that. Then the last term is a linear function squared, 3t over 5 minus 8, whole thing squared. Then you say, using graph or d dash t equals to 0, or if you wish, you use f minimum for t between 0 to 60. Your t value is what? Your distance minimum is what? Okay? I only do the rounding at the last step, okay? At the last step. All right, so that is question 4. Let's proceed with question 5, 6. Okay, question 5, 3 points ABC. Show that ABC do not lie on a straight line. That is not collinear. There are thousands of methods. I will demonstrate one. Firstly, I'll get AB equals to 1i, 0 minus 1, 3 minus 1 plus 2j, 3 minus 2 is plus 1k. And BC, for example, is 3i minus 1j minus 1 take 3 minus 4k. Suppose AB is a multiple of BC for linearity. Then you will get 1 equals to 3m, 2 equals to minus m, and 1 equals to minus 4m. M equals to 1/3, M equals to minus 2, M equals to minus 1/4. Contradiction. Contradiction or contradictory. Therefore, A, B, C are not collinear. The key to this question is establish a contradiction. The next thing is find the Cartesian equation of the plane P. Well, you have already obtained AB and BC. You could just do a cross product. There are different forms, but all equivalent of that equation P. So firstly, let's do BC cross AB, or you might want to do AB cross AC or BA cross BC or whatsoever. Eventually, it will give the same direction, the same line perpendicular to the plane, okay? And 3 minus 1 minus 4, 1, 2, 1. Actually, this is a tech active. I don't have to show this, but you could get your CAS calculator to work it out, okay? For example, you might want to do cross P. 3 minus 1 minus 4, 1 to 1. 7 minus 7, 7. Okay? And then you're chalking a point. You may just get a 1, negative 1, 1 to make your life easier. A Cartesian equation is x minus y plus z equals to some constant d. And you choose a point, let's say the easiest point. 0 takes 3 plus 3 equals to d. D is 0. So x minus y plus z equals to 0. Okay? Okay, that is done. Let's have a look at our next two parts. Now consider the plane Q given by 2x minus y plus 3z equals to 1, and the line L given by RT equals to I 2 minus 2j plus 3k plus t times 2ij minus k. T is a real number. Show that the line L does not intersect the plane Q. So the most direct method is get the parametric form. You get x equals to 1 plus 2t, y equals to negative 2 plus t, z equals to 3 minus t, okay? And solving Q. 2x minus y plus 3z equals to 1. So you have 2 plus 4t, or 2x, minus 2 plus 2 minus t, minus y, plus 9 minus 3t equals to 1. So eventually you will be able to get a 4t minus 3t, 0t. 0t plus 14 equals to 1. This is false. So no solutions. And no point of intersection. Between L and the Q. That's it. This is really a generous 3 marks question in my opinion. But you do have to show clear, concise working with good mathematics logic, okay? It's also another example of a proof by contradiction, I suppose. And finally, find the shortest distance from the line L to the plane Q. Well, from the line L to the plane Q, this is actually telling you, okay, this line is sort of parallel to the plane, okay? What you could actually do is, let's say you pick a point, let's say 1, minus 2, 3, which is coming from here along the line L, okay? And I get a point from the plane Q, okay? Let's say this is A. Actually, I shouldn't use A because A was used before. Let's call this, no, not P. Let's try to use M, okay? And call this point N. Find a point on plane Q. Let x equals to y equals to 0. You should be able to get 3z equals to 1, so z is 1/3. So let's name this as N. Point N is not 1/3, okay? Point M, 1 minus 2, 3. So vector N to M equals to 1 minus 0, let's say 1i minus 2j, 3 minus 1/3, plus 8 over 3k, something along these lines. And then the normal vector to the plane is 2 minus 1, 3. So eventually I'm just doing a scalar resolute to find the shortest distance between the line L and the Q, okay? Don't forget to put a magnitude or absolute value there, okay? Unit vector n hat. The magnitude is 2 squared, 4, 4 plus 1 is 5, 5 plus 9 is 14, okay? And then 2i minus j plus 3k. Take out a 1 over square root of 14. 1 times 2 is 1, minus 2 minus 1 plus 2, and plus 8, I suppose. Did I do this properly? Let's have a look. That should be. It's 1 times 2. That's 2 here rather than 1. Okay, so you should be able to get a 12 divided by root 14. And you could simplify this as 12 root 14 divided by 14 and get 6 root 14 over 7, I suppose. Okay, so that is the really straightforward vector lines planes question. Okay, question 6. A process to manufacture a particular type of vinegar involves the conversion of sugar. It is known that stopping the conversion process after 4 weeks results in the sugar concentration being approximately normally distributed with a mean of 0.37 grams per liter and a standard deviation 0.12. The vinegar is bottled for sale. Okay, so X is a normal distribution, 0.37, 0.12 squared. That is population distribution. Write down the mean and the standard deviation for the sampling distribution. Sampling distribution, 9 bottles, n equals to 9. So the expected value of X bar is still the mu, that is 0.37. The standard deviation of X bar is sigma squared divided by, actually, sigma, that's the variance. We need to write the standard deviation divided by root n. So it's 0.12 divided by root 9. So that gives you 0.04, okay? Grams per liter, grams per liter. Okay, what is the required minimum sample size so that there is a 90% confidence level? Let's say Z equals to 1.6448, dot, dot. The true mean concentration of sugar is within plus or minus 0.05 of the sample mean. So we would like the margin of error. This is Z times sigma divided by root n is less than or equal to 0.05, okay? And if you solve this by your CAS calculator, you should be able to get n greater than or equal to 15.5839 something. So the minimum whole number sample size is 16, okay, according to the inequality. Because when the margin of error is outlined, you would like the sample mean, let's say, or the true mean lies within this region, less than or equal to this region, rather than outside, okay? So you have to set it out like less than or equal to, and then solving this would result in a greater than or equal to. Okay, let's have a look at the last few parts. A shorter manufacturing process for the vinegar is proposed, which only requires 3 weeks. A random sample of 56 bottles containing the vinegar made by the shorter process has the shorter process has the mean sugar concentration. Oh, why is that higher? Because that's less sugar used, okay? Well, I don't really want to go into the detail of chemistry, but here is a possible equation. This is what we typically call the incomplete it's not combustion, incomplete oxidization, okay? So we don't just generate purely H2O or carbon dioxide. We may end up with some sort of, smaller carbohydrates, okay? Smaller molecules like a vinegar, okay? That's why the shorter the process, the less product or yields we have, the more reactant remaining, okay? Shorter process, more reactant remaining. We haven't consumed that much sugar. A one-sided statistical test at a 1% level of significance will be conducted, okay? Alpha equals to 0.01. Whether the shorter process results in a higher sugar concentration than the original process. Assume the standard deviation is still 0.12. Suitable null and alternate hypothesis. Well, this 0.41 is your sample mean. It's not your population mean, okay? So we still compare mu with the original 0.37 and H1. We suspect a higher mean level, so it's greater than, mu is greater than 0.37. Try not to just write H1 greater than H0 equal to. You must state the parameter, okay? Find a p-value for this test correct to 3 decimal places and draw appropriate conclusion about H naught. Give a reasoning involving p for your conclusion. So this is telling you, okay, sigma equals to 0.12, n equals to, the question says 56 bottles, 56. Your x bar is 0.41. Your mu naught is 0.37. And what else? And it's the mu greater than mu naught, okay? So it's a good time to exercise your button pressing process. Menu 671, choose stats, okay. 0.37 original mean, 0.12 original standard deviation for population, 0.41 for sample mean value, 56 bottles, greater than for H1 or H8. Press OK, control enter. The p-value is 0.0063. So we do have evidence to reject the null hypothesis, okay? Okay, let's move back and complete the last few parts. Make sure you quote the correct level of significance, okay? It's not 0.05. It gets so used to 0.05. You need to read through the question. 0.01 here, not 5%. Strong evidence. Or you could say this is very strong evidence to reject H naught. Okay? Optional, therefore, the mean sugar level is believed higher than the original. Okay? This is optional conclusion in the context of question. Find the largest mean concentration of sugar that could be observed from a sample of 56 bottles for the null hypothesis not to be rejected at the 1% level of significance. Draw a diagram here. This is X bar, normal distribution, 0.37, 0.12 squared divided by 56. So this is my sample mean distribution. We want to find the critical value of that distribution. So here we just have 0.01 area. So previously, using the left tail, we need to make sure the blue region covers 99% of the area. So 0.99. Let's name this thing as C star. So C star is the inverse norm. 0.99, 0.37, 0.12 divided by root 56, because we need to use the dilated standard deviation for X bar. So pretty much. Three decimal places. Well, it's often a good discussion around the way we correct our answer to 3 decimal places, like should I use 408 or 407? In this case, the question says not to be rejected, so we need to truncate this bit. And if we truncated this bit, it will still lie within the blue region. So the answer is 407 rather than 408, okay? Okay, 3 decimal places. Okay, last part. Assume that the true mean concentration from the shorter process is 0.40. This is what we call the mu1, the actual mean equals to 0.40. And the standard deviation is still 0.12. A sample of 56 bottles is taken. Find the probability of type 2 error for the one-sided test if the level of significance is changed to 5%. So many students tend to, naturally follow part E and get part F down. Actually, this was under 1% level of significance where we changed the level of significance for the last part. So we're still using the same curve, but there's one thing you need to be aware. This is another critical value, okay? It's no longer 0.99, it's 0.95 here because we are going to use 0.05 here. This is slightly larger, okay? This is slightly larger. So we still find the critical value under the old mean. This was mu0, okay? So C2 star equals to inverse norm. 0.95, 0.37, and then 0.12 divided by root 56, okay? So you will get, let's say, 0.396376, something like that. And now, just notice, this was my mu0, which is 0.37. My actual mean is 0.40. Therefore, I would draw a slightly different curve located somewhere else. This is mu1 equals to 0.40. So what I'm trying to find is the opposite. Okay, the opposite. The part I indicated in yellow, that is my type 2 error. Probability type 2 equals to probability X bar is less than or equal to C star 2, given mu is 0.40. So we actually find norm CDF minus infinity 0.396376, 0.40, but we still use the same standard deviation because the spread of both curves are the same, okay? Same width, same spread. Calculating this bit using your CAS is 0.4106, something along this line, and you get a 0.4. Okay, correct to 1 decimal place. Really generous. Hopefully you guys find this video helpful in some way. Whether you are a student, a current student, or ex-student, or a current teacher to specialist math. All the best for your November exam preparations, teaching and learning. I'll see you in the near future. Bye.